Hello, class. This will be the recorded lectures for the last topic in chapter 4. We're all happy to get to the end of chapter 4. And fortunately, another quite challenging section. And so this section actually kind of brings this whole chapter together. And what I mean by that is that at the beginning of the chapter, we introduced a bunch of identities, starting with basic identities, Pythagorean identities, some different formula, product sum formulas, double angle formulas, blah, 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 right? Nice sheet of all the formulas that we need. And then we introduce this technique on how to solve a trigonometric equation for all angles. And the idea is to find the angles between 0 and 360, and then deal with the periodicity or the periods of each one of the trig functions. Because they sine and cosine repeat every 2 pi or 360 degrees, and tangent repeats every pi or 180 degrees. So now we're going to kind of bring that all together, where we're going to solve trig equations to find all valid angles. So that means we have to deal with the period. But now instead of what we're going to add to this is that some of the identities are going to be applied to it as well. So let's just jump right into this. And I'm going to go through a variety of different examples. And what we're going to start with first is this idea of solving trig equations by using identities. And so we're going to use identities and then solve for all possible angles. And so in this section, we first must simplify the equation and so we could solve it for all the angles. And so in this next first example that we're going to talk about, you'll see that we're going to be able to do some factorization. So again, algebra on steroids, right? Algebra with trig functions. But here is an issue. And so let's just jump into the first one. So we have 1 plus sine of theta equals 2 cosine squared of theta. Okay, so what do we do? Well, you look at that and you say, well, there's no nice way to factor it. And no nice way to isolate both of those variables, right? And so when you are stuck with something that looks like this, usually the strategy is that if you could get all the variables into a single trig function, right? What do we mean by that? Well, you have sine and cosine on both of these, right? Well, if you can just make them all cosine or all sine, that would be great. And so one of the things that you remember, hopefully this is the only one I remember, right, is the Pythagorean identity, right? And so in this case, we have sine squared plus cosine squared equals 1. So what we're going to do is we're going to get rid of the cosine squared and put 1 minus sine squared. And so now we'll have everything in the sine squared and sine, and then we'll see what we could do with it. So when we do that substitution, 1 minus sine squared of theta. So then we'll do a little bit of algebra. And multiply the 2 through. And now just to remember your algebra again, right? This looks like a quadratic where we have a sine squared and a sine. And remember, when you solve quadratics, what you would do is bring all the variables to one side and set it equal to 0. And so that's what we're going to do again. So we're going to bring both these variables to the other side. So this would be a minus 2, right? And then we would have to add 2 sine squared of theta. So when we do that, I'm going to write it this way, 2 sine squared of theta, and then plus sine of theta, and then 1 and a minus 2 gives us a minus 1 here, and that would equal 0. And so let's set y equals to sine squared of theta. And look what this equation turns into, right? A nice quadratic. And so when you look at that, what you're going to have to think about is the factorization part of this. And so if we do that, we end up with 2y and then y. So y times 2y is 2y squared. So we need a minus and a plus here, right? So that when you multiply the 1 together and minus 1, you get minus 1 for our constant term. And you could see that you get plus 2y minus y gives us y. So that would equal 0. So then what you want to do, I need a little space here, so I'll just erase this, is now I will resubstitute our sign back in and see what we get. So when we do that, you see you get 2y. Whoops, I'm supposed to substitute in, didn't do that. So 2 sine of theta minus 1 times sine of theta plus 1 equals 0. And then when you do that calculation, right, what we want to do now is to make those equations true, each one of those factors have to equal 0. So the strategy, just like we did in the previous section, after the simplification. So here we have 2 sine of theta minus 1 equals 0. So that would be 2 sine of theta, bring the 1 to the other side, and then sine of theta equals 1 over 2. So what are all the values that make this true? Well, remember, sine is positive in what quadrants? Quadrants 1 and quadrants 2. So if you take a look at our matrix, this is a nice number, right? So sine of 1/2 in quadrant 1 is 30 degrees or pi over 6. So that would be in quadrant 1, pi over 6. And remember, we do that 2 pi k thing, right? Where k is any integer. And so that is the period. So what would it be in quadrant 2? Well, again, we have our triangle this way. This is going to be 30 degrees. So when we go all the way around, that's going to be 180 minus 30. And so that would be 150 degrees. And what is that in radians? For our favorite webasine, that would be 5 pi over 6 plus 2 pi k. So far, so good, hopefully. Okay, so that's one. And so the next one. Sine of theta plus 1 equals 0. Sine of theta equals minus 1. So if you think about that one, where is sine minus 1? Well, it's 0 plus 1, 0 minus 1. So that's 270 degrees or 3 pi over 2, right? And so that would be 3 pi over 2 plus 2 pi k. And you say, a lot of work, right? And we finally get to the end and you're not quite done. Because when you do these transformations, especially when you start plugging in identities and you have the aspect of doing these factorization, is sometimes when you do these simplifications, some of the answers work and some of them don't. And I know you were familiar with that in algebra when you were solving radicals, for example, and you squared both sides, then you had to double check and make sure everything worked. Here is just another aspect of math. So now once we have these, we need to double check and make sure they work. And how do you double check them? You plug them back into the original equation. So let me do that for you. Whoops. So when we take a look at that, let's start with 3 pi over 2. That should be the easiest of the ones, I think. So that would be 1 plus sine of 3 pi over 2 equals 2 cosine, whoops. Cosine squared of 3 pi over 2. So what's sine of 3 pi over 2? Well, we know that's minus 1. We did that there. So that's 1 minus 1. And what's cosine of 3 pi over 2? Well, that is down here. And so cosine in that spot would be 0 at 270 degrees. So that would be 2 times 0 squared. And the 0 equals 0. Yes. So this one is valid. And you say, cool, that one worked. Okay. Angle number 2. And once you try one of the angles, when you go the 2 pi, you don't have to try every angle. Impossible to try, right? So you just try all the base angles, as I like to use them. And let's try pi over 6. So this would be 1 plus sine of pi over 6. Well, not 2, 6 equals 2 cosine squared of pi over 6. So what do we have here? We have 1 plus, and we know that's a half, right? So this side here would be 3 over 2. And let's see what we get on this side. So we get 2. And so if you look on your chart, pi over 6 cosine is square root of 3 over 2. And then we're going to square that. So what do we get? 2 times 3 over 4, right? And then you can cancel these out here, and this would go to 1, and this would go to 2, and it looks like that one works as well. So you could see that 3 halves equals 3 halves, and away we go. So this one's okay too. So let's see about the last one. Okay, so let's do this one, quick check. Let's see what we got. Wish my whiteboard was bigger. So this would be 5 pi over 6. And so again, 1 plus sine of 5 pi over 6 equals 2 cosine squared of 5 pi over 6. So what do we have in this case? Well, in this case, we have sine of 5 pi over 6 should be plus 1/2 again, right? Because that's what we ended up with. That's in quadrant 2. So that would be just like sine of 30 degrees. But what do we have here? 2. And then 5 pi over 6 in quadrant 2 would be square root of 3 over 2, but negative, right? Because we're in quadrant 2. So this would look like minus square root of 3 over 2. But guess what happens? We square it. So now it turns positive again. So it looks like we're okay. So this ends up turning the same as we had before. And so this would be 3 halves equals 3 halves. And so it looks like all 3 of these work. And so as you can see, every problem is going to be a little bit of time. And so the good news is we only have one section that we're going over this week. The bad news is each problem is, it takes some time. So I recommend starting this sooner rather than later so you can make sure that you can get through these. So let's do one more problem before I call it for the first of many lectures on this section. And so let's take a look at this one. And so this one's kind of nice because the way this one's defined says cosine of theta plus 1 equals sine of theta. And so this idea is sometimes they'll say, don't find all the angles, but just find all the angles that are valid between 0 and 30 degrees, right? And so what do we do? So you look at that and say, I don't know, right? Well, you know, the most important of all the identities is the Pythagorean identity. And so it's really nice to have squares. And if you don't have them, maybe you need to do them. And so that's the strategy in this case, is what we want to do is we want to square both sides. Because then we could think about the Pythagorean identity and see where that takes us. Because to solve this way, with cosines and sines like that, it's pretty hard. And so with regards to this side would be sine squared of theta. And this would be cosine squared of theta plus 2 cosine of theta plus 1. Now we could use the Pythagorean identity again. And when we do that in this calculation, we would get cosine squared of theta plus 2 cosine of theta plus 1 equals 1 minus cosine squared of theta. So now, same strategy, right? We move everything to the other side because we got a quadratic. So we have 2 cosine squared of theta because we bring the plus over. And then we still have 2 cosine of theta. And bring the minus 1 over, that equals 0. So that's not bad. So we don't have to do a crazy factorization, right? So what do we have here? Well, we have so we're going to factor out the common factors of both of these terms here. And so the common factor is 2, and we have cosine of theta in both of them, right? So what's left in the first term? Well, since we have a square, we still have 1 cosine left, and that would be plus 1 equals 0. So what do we have? Well, we have 2 cosine of theta equals 0. So where is cosine 0? Well, remember cosine of 0 is at 90 degrees and 270 degrees. So this would be pi over 2 or 3 pi over 2. Okay, and then the last one is cosine of theta plus 1 equals 0. And so when we take a look at that, cosine of theta equals minus 1. And where is cosine minus 1? That would be at 180 degrees, right? If we look at the unit circle. So that answer would be pi. Okay, so again, unfortunately, we have to plug all these in, see what happens. So let's do that. So again, try to get a jump on this homework. If you wait till Monday after class to try to finish it Monday night, it'll take you a while, just to warn you. So when we take a look at this, we'll start with, what do we start with? Let's start with pi over 2. So that would be cosine of pi over 2 plus 1 equals sine of pi over 2. So what is cosine of pi over 2? Well, that would be 0. So 0 plus 1. And what's sine of pi over 2? That's 1. Okay, so this one's good. Cool. Next stop. 3 pi over 2. So we walk through 3 pi over 2 and 3 pi over 2. So we look at that, and again, this would be 0 plus 1. And what's sine of 3 pi over 2? Minus 1. Doesn't work. So you can see what I mean. Sometimes when we do that square and factorization and stuff, sometimes we'll end up with some answers that will be off, and they're typically off by like this. One side will be a negative and the other side will be the opposite of it, or the positive one. So you can see that this one does not work. And so the last one to try would be pi. So this would be pi, and this would be pi. And here we'd have -1 plus 1. Sine of pi is 0. 0 equals 0. And so that works as well. So the two answers are pi over 2 and pi. I put it on pause there real quick because I pulled up WebAssign here just to show you that, say the first part of this homework is problem 1, right? Where we have 2 sine squared of theta plus cosine squared, or plus cosine of theta equals 1. Pythagorean identity again to simplify it. And you'll see that the next one has no solution, but you have to prove that. And again, idea of Pythagorean identity will be quite helpful with that. And so you'll see that the first few in this section here all have this idea. Remember, this is one that we just did again. Here you'd want to square both sides and 4 and start using the Pythagorean identity again. And so we're throwing in secant there as well. And so what you'll want to do in the secant one is to use the Pythagorean identity for tan and walk through that one as well. So you'll see that the first quarter of the homework will be very similar to this. So that ends the recorded lecture for part A. There's going to be a few parts in section 4.5.